Now we're going into using it. So we have those tools. We assume that we can find derivatives of many different things. Now, where do they get used? So, as we said before, we're looking for, like, maybe this represents kind of profit. Okay? So we're looking for where the profit would be high. So this might be the number of things that you manufacture. Now, this doesn't make sense in that case because you don't manufacture a negative amount of things. But suppose we just shifted everything over to the right. Okay, so we want to know how many things we should manufacture to get the highest profit, for example. Okay, so the first thing they do is they want to be clear about what we mean by a high point and what we mean by a low point. Now, obviously, you know what we mean by a high point and a low point, but they make some very technical language about it. Okay, so first of all, they use the word extrema. Extrema just means either a high point or a low point, an extreme value. Okay, so that's the first word that they come up with. And then they come up with the concept of the absolute high point versus what's called a local high point. And that is because here, if you take this graph, so where is the highest point on this graph? Well, there isn't kind of a highest point, but you might say maybe over here. It's the highest point, maybe where the graph ends is the highest point, where the function gets highest. Okay? So that might be a kind of an answer. But that completely ignores this situation, right? But this is a kind of a high point, right? Right? It's something we want to identify, right? We might be interested in this point, so we want to give it a name. Okay? So this is not the absolute high point. So we have to come up with another word. And so it's called a relative high point or a local high point. So that's just a word that we use, okay, to separate from the absolute high point. And when they don't use high point, they say maximum. Okay, so this is maybe over here is the absolute maximum, and this is a relative maximum, okay, or a local maximum. All right, so we just want to develop a vocabulary for talking about the different kinds of places that we're interested in. Okay, of course, we can also talk about relative low point. Right? I don't know if I have a picture here yet. So this is not the absolute lowest point, right? This is lower, but this is a relative minimum. Okay, this is called a relative or local minimum. Okay, I think this book uses relative, but other books use the word local. All right? So here it says, F, now you're supposed to do this, it says order your answers from smallest to largest x. So in terms of the x-axis. So in other words, F has a what? A relative minimum at blah, blah, blah. No, you shouldn't do that because, we want to go from left to right. So what's the first thing we're going to be talking about among these things? Relative minimum, relative maximum, absolute minimum, absolute maximum, no. This one is the furthest left, right? And this is what, in terms of this whole function, this is a absolute minimum. So you'd say absolute minimum, then you have to give the coordinates of this point is -2, 4, 6, right? -6, comma, -2, right? So you have to type that in here. Okay, then the next one would be what? This one, that is not an absolute maximum, but it is a what? Relative. So you'd say relative maximum here, and you'd have to give the coordinates of that. And then the next one would be what? Relative minimum for this point here. And then the last one would be absolute maximum. Okay? So we're just, as I said, we're just trying to get a vocabulary of, like they say, Eskimos have more than 100 words for snow. Because, they live in snow, so they're very attentive to snow. right? So there's all different aspects of snow, right? So same thing here. We want to be attentive to the different kinds of maximums and minimums. So we're developing a vocabulary for that. Okay? After we develop that vocabulary, then we want to go about and figure out how can we, if we're given an equation for some curve, like here we're just given pictures, but if we're given an equation for a function, how can we find the highest point on it, right? Like we don't know the graph of it, right? Because how are we going to know the graph of an equation, right? We don't have it, unless it's a simple equation, we don't know. Like if I gave you that one of these hard functions up there and I said, what's the equation of that? I don't think you have any idea, right? Right? But we'd like to do two things actually. We'd like to find the maximums and minimums and local relative maximums and minimums. And also ultimately we'd like to get a picture of the graph, right? But how are we going to do all that? With the derivative. Derivative is going to help us, especially to find the local maximums and relative relative maximums and minimums, and absolute maximums and minimums might help us there too. Okay? So, and then it will help us to sketch the graph. So that's what, that's what this course is about, and that's what, you have to do a lot of that kind of stuff when you're working with other fields. Finance, marketing, economics, and then sciences also. Okay? So after we finish the course, you should be able to do that kind of thing. All right? So this is the next homework, which is due not until the 11th of next month, but it doesn't mean you can't do it sooner. Okay, we didn't do the derivative of the log function yet, but we already talked about the derivative of the exponential function, right? E to the x, the derivative of e to the x is e to the x. Okay, but we didn't do derivatives of logs yet. Okay? All right, next week we will meet in this room, and then we will move to but don't be late, because the exam will be over before you even get to class. Okay? I won't give you an extension for the exam. So if you're not here, we'll move to most probably one of the rooms, just to let you know, in case you come in late, over there, one of the IPS rooms over here, which we'll have to get one that's open. Okay? But if you're late, you don't get extra time. Okay, so, yes? No, as I said, it's only up to this one here, 620. Actually, I think I made a mistake at the beginning of class. I was looking at the wrong one. I was looking at this one, which is my other class. But anyway, for you guys, you're responsible for up to here. Intro to derivatives algebraically. No, because this is only the current ones. So the past one. Anyway, okay, up to that, including that. All right? Everyone understand? So from here backwards, that's what the exam will cover. All right? And as I said again, don't be late to class. Okay, that's all.